Hi guys, all of you, good evening. And guys, welcome back to DevOps 29th class. Guys, it's a very important concept. So why I'm saying that important? Of course, previous classes also very important. And this is this class is a little bit some more extra important because now we are in one important role. I mean that we are going to set up in one important concept, important tool in the DevOps flow. The DevOps flow. So what is the tool? The tool is Maven. Just let me show you that. Tool is Maven. Guys, I think already we are having one flow idea. So what is the DevOps flow? What is the DevOps flow, guys? Yes, we are having. So the first where it starts is the first one. Yes, first one, plan. Based on client requirement, or product requirement, we will design that plan. Based on this plan, yes, then this plan goes to coding. Code. Okay, guys. So programmers are writing based on client requirement or product requirement. They are going to developing the code. After developing this code, let me show you that once again the process. See, guys, code developing by this. Programmers are going to developing the code. Programmers are developing the code. After developing this code, what they will do, guys? They will centralize the code. They will centralize the code. This is the DevOps flow. This is the DevOps flow. So how the DevOps will flow and practically we'll see that. See, programmers are going to writing their programs. After that, they are going to centralizing the code in one repository. That's calling as a SCM repository. SCM repository. Source code management. That's calling as a source code management repository. You can use any one, GitHub, Bitbucket, RPRForce, RTC, SVN. Like there are so many tools are there, but we are using Git, source code management repository. Okay, guys. We are using this. Guys, up to here we know that. We saw that. How to pull the code, and how to push the code to SCM server. Guys, nothing to worry. As a DevOps engineer, need not worry about this coding. Need not worry about this coding part. Okay, simply we can get the code from the SCM to build location. See, guys, this part is belongs to programmer. Programmers are writing their source code. After that, they are going to centralizing the code. Is checking source code. They are going to check in the source code. Now, what we are doing that? See, guys. Now, in the DevOps flow, in this DevOps flow. Yes, build. Programmers are going to writing the code. After that, we are building the code. So what is build? What is build? Guys, build nothing but simple, in simple meaning converting source code into executable format. Whatever the programmers are going to write in their source code, we are pulling the code from SCM to, yes, this is the CI/CD server. CI/CD server. Here we are using Jenkins. See guys, after completion of check-in by the programmers, so what we are doing that we are getting the code, or we are pulling the code from SCM to CI/CD server. So already we know that. Already we saw that. How to get the code from SCM to GitHub. We are using that GitHub. From GitHub to Jenkins server. We saw that in previous projects, previous tasks. If you haven't seen that, yes, you can see that guys, previous videos. So how to get the code from GitHub repository to Jenkins server. So after here we saw that. So guys, after getting this code into Jenkins, what next? Yes guys, the important, there are different ways. Yes, one is we need to check the code quality. We need to check the code quality. We need to check the code quality, guys. For checking code quality, we are using Sonar. We are using SonarQube. SonarQube is a code quality tool. SonarQube is a code quality tool that is used for to check the code quality. So code quality mean, guys, just I'll show you one example here. Just I'll show you one example. Very simple program. Some .java or multiplication or whatever you can take that, guys. Yes, class sum. Yes. See guys. Okay, program. Yes, now int a comma b comma c, a equals to b equals to c equals to, guys, c equals to a plus b plus c. This is the program. Now system dot out dot println, no need, sum of values are, yes, plus c. See guys, this is the program. If you send this program to SonarQube, 100% it will reject it. The reason, of course, we can compile the code successfully. Just let me show you that. Let me show you that. Yes, git bash. Open here git bash. Yes, yes, the VAM sum.java. Yes, this is the program. Now what we are doing that? So guys, we are going to compiling this one and we are going to executing. So in the same time, we can see that how we can build. What is build? What is build? We can see that, guys. Now, yes, we are having that Java C sum.java. Yes, semicolon missing. Yes, escape. Now we can apply the same program. See guys, successfully we have compiled. If you observe this one, you can see, just wait guys. You can see one more program with the name of sum.class. See guys, this is the executable program. This is the executable program. This is the source code. Now what we are doing that? Yes, we built this one. We compiled, successfully compiled, and if you run this program, Java space sum, just see guys. See the total output is 210. Yes, the code. See guys. See 90 plus 120, 210. Program successfully compiled. Program successfully compiled. But if you send this to SonarQube, what it will do? What it will do that guys? 100% it will reject that, because it's mean why you have repeated this one again and again. Yes, C, A repeated, B repeated, C repeated. The same program. The same program. Yes, come here. If you, yes, cp sum.java space someone.java. Now, yes, VAM someone.java. Yes, open this one and just someone. See guys, now same one. Yes, you can come here equals to 60 equals to 30 and equals to 120. Now you can come here, just remove this one. See guys, simple. So it means we are going to reducing the code. Quality is important, not quantity. So always SonarQube will check. SonarQube will always concentrate on code quality, not code quantity. Now you can apply this one. Yes, save this one. Just Java C someone.java. See guys, successfully compiled. This one also. Now we can apply that. Yes, Java sum one. See guys. So this is the importance of code quality. So whenever you send this code to SonarQube location, 100% it will reject, because it won't accept that repeated statements, unnecessary statements, unnecessary coding. So what is the importance of code quality? Why we need to check code quality? Guys, whatever the program is there, if it is logically correct, if it is successfully compiled and it's running successfully, but maybe the code having huge quantity, for small size output, also, maybe the program having huge quantity. So whenever you are going to sending this, or whenever you are going to building this program directly without testing code quality, so what will happen? That product moves to production environment. Once we deploy into the production environment, the production server will be in trouble. It will be in trouble. Reason. What are the reasons for getting trouble? Yes, it will consume that huge RAM and processor and disk space and networking. So whatever the resources are there, it will consume unnecessarily for small program also. So whenever it will consume that huge resources, automatically that performance will decrease. So that reason we need to check the code quality before building the product. Before building the product. Okay guys. So that's a little bit important. Of course, we are having some more important concepts. We'll see that. But this is the one basic and important key point in this code quality. So in this case, what we are doing that, yes, we need to send the code to code quality. Okay, that is the importance of code quality. So once the code quality is okay, now see guys, its code quality is okay and it's builded. Of course, we didn't test that code quality. We didn't test that. So we will integrate guys. Once we finish that Maven, then we will go for that Maven SonarQube integration with Jenkins. We will configure one separate server for code quality by using SonarQube. Then we will send the code to code quality location. Yes, the code quality server will take the code and it will test and analyze and it will throw that box and that code quality warnings and errors. Based on that warnings and errors, yes, we can modify the code and we can test the code of something that yes, we can revise the code. Okay, guys, we'll see that later on that. Now, right now, we are not using in today's session. Okay, so until when we finish this Maven and okay, we are not using this SonarQube. Once it's over, then we will go for this code quality case. Now, so forget about this one. Of course, if code quality is not okay, what will next? What next? Yes, guys. Yes, we are sending to programmer. Yes, we are sending to code development team. We'll send that all respective team members. Okay, guys. If code quality is okay, what next? Yes, we are sending to the pipeline. If you are using that pipeline, upload. Yes, we are sending to build tool. That's okay. Build tool. Guys, here we are having different build tools. Yes, Ant is there. Ant is there. Gradle is there. Maven is there. MS Build is there. Like that, different tools are there. But it depends on that code also. If it is related to MS .NET, Microsoft .NET code is there. Yes, we need to use that MS Build. If it is related to Java, yes, we need to use that Ant or Maven. Now we are using that Maven. Yes. What is the Maven? Maven is a build tool. Maven is a build tool. It is used for to test the code quality. To test the code quality and to build the product. We are using we can test the code quality by using unit tests and we can build the product. Build mean see guys, just now see here we are having this is the executable product. So whatever we are having these .class files, these are the executable products or executable files. Of course, Java also having that build process. We can build the product, but one more tool is there. There's the Maven. By using Maven, yes, we can convert into executable format. We can convert source code into executable format. Okay. To sum up, Maven simplifies and standardize the project build process. and it handles team collaborations, compilation, distribution, documentation, and separates tasks seamlessly. We can manage. Okay, guys. So it increases this reusability and also take care of most of the build related tasks. See, guys, right now we are having only one program. Right now we are having only one program. If it goes to real time environment in real world, there are hundreds of programs are there. One or more programs are there. If you observe that one project can contain one or more programs, minimum to minimum 15 to 20, 100 or 200, 300, 500 programs. We can't compile at a time, all at a time. Of course, we can compile, but a little bit difficult. If you hand out to Maven, Maven it will take care of that code. It will test, it will validate, it will compile, and it will install the required plugins based on our requirement. Okay, guys. It works and help many steps. It helps us so many steps, such as adding jar files, adding the var files, adding the jar files and ER files based on the pom.xml. We'll discuss what is that pom.xml. We'll discuss that. But Maven playing main key role nowadays to build mean keep in mind simply convert from source code into executable format. So executable format mean, see guys, if you run this one, we can't see that output. It's the source code. But if you try to see guys, yes, I'll show that. Yes, cat sum.java. See guys, this is the source code. Same command, if you apply that one class, see, yes, it converts into mission understandable format. It's the executable code. We can't understand, but system can understand. Now, this is the executable program. By the source code, we can't. For converting this format, we are using the command. The command are tools. For executable format, we are using tools like that. Ant is a build tool, Maven also build a tool, Gradle also build a tool, MS build also build a tool, and so many tools are there. Plenty of tools are in the market, but very famous for Java, yes, Maven. Maven is a build tool. It's next to Ant. Maven is a build tool. This tool next to Ant. Before this Maven, yes, there is one more tool that's calling as a Ant. Ant also build a tool that is also Apache organized, or that product also developed by Apache organization. This Maven also developed by Apache organization. Okay, guys. Now we are going to discussing about that tool, how we can, why we can, okay, where we can use this Maven, what is the importance of Maven, we will discuss, guys. Okay, thank you. We will see in the next session, guys. Thank you.